This is my presentation on the material research of ferrofluids. So my research question is, how does the molecular structure of ferrofluids allow it to protect hard drives? And in this case, hard drives means anything that you use to store or back up information on. So it can be computer hard drives, external hard drives, whatever the case may be. So here are my bulk scale photos. I wasn't able to find an open hard drive, and ferrofluid on its own is very expensive. But ferrofluid sits under the disk of the hard drive, and it looks like this when it's subjected to a magnet. Otherwise, it kind of looks like soy sauce when it's not subjected to a magnet. Okay, so some bulk scale properties are that ferrofluid is a solid and a liquid. It's oily and very slippery. It's thick, but it's not very dense, and it takes the form of the container much like a liquid unless it's exposed to a magnet. So, ferrofluid in its molecular structure has three main parts. It has nanoparticles of iron, surfactant particles, and oil particles. The atoms are arranged within one nanoparticle of iron, surrounded with oil particles, and the surfactants are placed randomly. But the nanoparticle of iron and the oil particles have strong intermolecular forces because of Brownian motion, and this is a new theory that I came about in my research, which is liquid's tendency to keep on moving, keeping the particles that it's holding suspended. And so the surfactant is made up of tons of chemicals, too many to name, but like one of them is a phospholipid, and acts as a film to keep the nanoparticles from becoming solids. So it maintains that solid liquid form, which is more important later on. And the atoms are arranged in random order, but when subjected to a magnet, they change. And a lot of the time, like ferrofluid is very normal until a magnet is subjected to it, and then we have the spikes come up. So this is my ferrofluid model when it's subjected to a magnet. So on the bottom here we have a magnet, and on the top we have a bulk scale version of ferrofluid, and so this highlights van der Waals theory of attraction and repulsion, and ferrofluid has attraction and repulsion simultaneously. But the thing of the spikes is that it replicates the magnetic field it's exposed to. So these dotted lines represent the magnetic field over here as well. So now if we zoom in into one of the tips of the spikes, we have a more clear version of what's happening in the molecules. So first we have these plus molecules represent iron, and these negatively charged molecules represent oil. And so again, these purple lines as labeled by the key are intermolecular forces by Brownian motion. And then we have these black lines, these black arrows, which is magnetic force. And this causes the particles of iron to be attracted with each other. They want to join with each other. And this is where the surfactant comes in. The surfactant are, as labeled by the key, are these red dots. And these red dots keep the particles from joining together, so that it still maintains its liquid form, but it has some sort of solid aspect to it. And this applies to protecting hard drives. So this brings me to my CER. The ferrofluid protects the hard drive because it acts as a lubricant, firstly, but most importantly, it holds the disk together using its forces and magnets to make sure it works effectively. So the main evidence for this claim is due to ferrofluid's molecular structure. Ferrofluids are solid liquids, which are agile substances, and ferrofluids are placed inside a hard drive within a spinning motor with a magnet under the disk. And so this allows less friction because it's a liquid, but it's also can also turn into a solid. But the fact that its base form as a liquid is that the disk can keep spinning faster. So ferrofluids are populated with nanoparticles of iron, oil, and surfactants. So the first thing we need to know is that it keeps the information together due to Brownian motion, which is liquid's tendency to move, and therefore the iron stays there. But the most important thing is van der Waals theory of attraction and repulsion, because when the hard drive senses that there's some sort of unwanted substance or maybe just simply dust, um, The magnetic motor within the hard drive turns on, spins, and makes the ferrofluid charged, much like the first picture, like this. And then the spikes either absorb the dust or absorb the unwanted substance or simply push it out. So in conclusion, the intermolecular forces and Brownian motion keeps the disk on rotate because the molecules are kept together, but not to the point of becoming a liquid. Also, the attraction from the magnet disperses the ferrofluid when the hard drive wants to get rid of substances. These are my works cited. Thank you.